Hello everyone, welcome to the 7th video on power spectral density. In the last session, we were introduced to a concept called as average power of the process or mean square value of the process and how to estimate them using two different techniques. One is going to be the inverse Fourier transform technique or using the usual integration formula of tan inverse, which we already learnt in our lower grades. Now we will move on to a level higher and see how this can be worked out in the next level of problem. The problem is given the power spectral density Sxx of omega. The value of it is going to be omega square plus 9, omega power 4 plus 5, omega square plus 4. We'll have to find the mean square value of the process. We know that the mean square value of the process is given by the value or the expression expected value of x square of t. This represents the mean square value, and in turn this e of x square of t is nothing but equal to rxx of 0. So in the general formula of the inverse Fourier transform pair for your power spectral density, replace your tau with 0. So this exponential function over here in this place, e power 0 will become equal to 1. So we have the formula as 1 by 2 pi integral from minus infinity to infinity Sxx of omega d omega. Now if we are going to apply the same over here, it becomes 1 divided by 2 pi integral from minus infinity to infinity. Our Sxx of omega has been given as omega square plus 9 divided by omega power 4 plus 5 omega square plus 4, and this is going to be with respect to d omega. I will have to integrate it. Now this is not an easy expression like what we had in the first problem. So the method which we are going to apply over here to solve it is called by the name partial fraction method or technique. So what we are going to do is we are going to consider this portion over here and we are going to split it into partial fraction and then put it back over here, and then we can solve them either using the inverse Fourier formula or using your tan inverse formula, which we have already learnt in lower grade. Okay, so what I am going to take is I am going to consider omega square plus 9 divided by omega power 4 plus 5 omega square plus 4. This is my expression. I will have to split this into partial fraction. Now as such, this is going to be an fourth order equation and you are going to have 4 roots for it. It will become very difficult for us if we keep power 4 to work. So what we usually do over here is we replace our omega square to be equal to, a quantity called as u. So this is going to be the technique which we are going to follow. So wow, this formula will now change as, format will change as u plus 9. So what will be omega power 4? It is omega square the whole square. So this becomes u square. So the denominator becomes u square plus 5u plus 4. So this is going to be the changed format for me, u plus 9 divided by u square plus 5u plus 4. Now again to split this into partial fraction, I will have to factorize my denominator. How to factorize your denominator? U square plus 5u plus 4 is going to be my denominator. So this is going to be my sum and this is going to be my product. I have to get product as 4. 4 into 1 will give me 4 and 4 plus 1 will make it as the sum, which is 5. So how I can split this as? I can split this as u plus 4 into u plus 1. So this is going to be my denominator. So I have my u plus 9 divided by u square plus 5u plus 4 to be rewritten as u plus 9 divided by u plus 4 into u plus 1. Now we notice that both the factors which is available over here are going to be different and they are going to be linear in nature. So I can just substitute one constant for my first factor a for u plus 4 and then give the second constant for your second factor as u plus 1. So this is going to be the partial fraction which we are going to now solve for. Okay, so what I have done, I have converted the problem which has been given to me into a partial fraction, so that the denominator now gets split and it will be easy for us for the further evaluation. Now how to go about finding the value of a and b? I have u plus 9 to be equal to cross multiply. So I have a times of u plus 1 plus b times of u plus 4. So to get the value of a and b, just equate the factors to 0. So when I replace u plus 1 factor to 0, substitute u to be equal to minus 1. When I do it on both sides of it, I have minus 1 plus 9 equal to a times of minus 1 plus 1 plus b times of minus 1 plus 4. Now this automatically vanishes one of the constant, leaving us with just the value for b. 9 minus 1, this makes it as 8 equal to b times of 4 minus 1, so that makes it as 3. Hence I have the value for b to be equal to 8 divided by 3. I have got the value for b. Now the next thing is to get the value for a. So what is going to be the second factor? My second factor is u plus 4. So what do I do is u plus 9 is equal to a times u plus 1 plus b times u plus 4. You equate the second factor to 0. So I have u to be equal to minus 4. Substitute u as minus 4 in both the sides. So minus 4 plus 9 equal to a times of minus 4 plus 1 plus b times of minus 4 plus 4. We know that minus 4 plus 4 cancels off one another, leaving us with just the constant a for estimation. 9 minus 4 makes it as 5 equal to a times of minus 4 plus 1 makes it as minus 3. So this gives me the value of a as minus 5 divided by 3. So now I have got my value of a and b. Let me go and put it back in my original quantity where I have split it into partial fraction. So now what do I have is my u plus 9 divided by u plus 4 into u plus 1, which was rewritten as a divided by u plus 4 plus b divided by u plus 1 is now got of the format minus 5 by 3 times u plus 4 plus b, we got it as 8 by 3, substitute it over here, 8 by 3 times u plus 1. Now what I want, go back one more step further. This is going to be the factor which we have, so I'll have to retrace it back. Where I'll have to retrace it back, the partial fraction is retraced to this format. This is now retraced to this format. So what I need to apply furthermore here, I'll have to replace wherever I have u as omega square. Let us go and do it. So this function will have my u over here to be replaced. So I have this to be equal to minus 5 by 3 times omega square plus 4 plus 8 by 3 times omega square plus 1. So I have my next step of u plus 9 divided by u plus 4. So this is going to be omega square plus 9 omega power 4 plus 5 omega square plus 4 has now been got of the format 5 by 3 by omega square plus 4 plus 8 by 3 omega square plus 1. Now let us go one step further ahead. Now we are in this stage. From this stage, what I need to do, I need to move to the next stage. What is the next stage? This is the input to the integration. So I will have to put my partial fraction in the integration, so that I will be getting the value of the mean square value, expected value of x square of t. So what I am going to do over here is my expected value of x square of t, which is nothing but my rxx of 0, is 1 divided by 2 pi integral from minus infinity to infinity. The fraction which we had, like omega square plus 9 divided by omega power 4 5 omega square plus 4 into d omega. Now this will now be replaced as 1 by 2 pi integral from minus infinity to infinity we had the partial fraction. What is going to be the partial fraction? Minus 5 by 3 divided by omega square plus 4 d omega. Let me split it into one more term. 1 by 2 pi integral from minus infinity to infinity 8 by 3 times omega square plus 1 into d omega. So this is what I have for my quantity. Now I know that I have two different methods which I can apply and get my final answer. So we will see what are those two methods. The first method is using our integration formula. I know that integral 0 to infinity dx divided by alpha square plus x square is 1 by alpha tan inverse x by alpha. So first I will change this integration. This is going to be an even function, so I can write this to be equal to twice integral from 0 to infinity divided by 2 pi. Let me take this minus 5 by 3, which is going to be a constant outside. So what will happen over here for me is going to be, I have minus 5 divided by 3 outside, integral from 0 to infinity d omega divided by omega square plus 4. In a similar pattern, this can be written as twice integral from 0 to infinity. Let me take this 8 by 3, which is a constant outside, so I will be left out with d omega by omega square plus 1. Now replacing this omega square over here can be replaced as, how I can rewrite this as, I can rewrite this as 2 square. So this is my alpha square, and over here this 1 can be written as 1 square. So now my alpha is going to be equal to 2 over here. So I have this part to be equal to 2 can be cancelled off, minus 5 divided by 3 pi times, this is going to be equal to 1 by alpha. What is going to be alpha? Alpha is going to be equal to 2 for me. So it is 1 by 2. It is going to be tan inverse of omega divided by 2 between the limits from 0 to infinity. How about the second term? Again 2 and 2 can be cancelled off. I have it as 8 divided by 3 pi. I have this 1 by alpha. Alpha is going to be equal to 1. So 1 by 1 tan inverse of omega by 1 between the limits 0 to infinity. Now the next step is going to be our simplification. So I have this to be equal to minus 5 divided by 3 pi, 2 3 2s are 6 pi. So this becomes 6 pi, and now tan inverse of infinity is going to be 90 degree and tan inverse of 0 is going to be equal to 0. So I have this as tan inverse of infinity minus tan inverse of 0. I have the next step as 8 divided by 3 pi, again tan inverse of infinity minus tan inverse of 0. So 8 divided by 3 pi, tan inverse of infinity minus tan inverse of 0. Tan inverse of 0 is going to be 0 and tan inverse of infinity is going to be equal to pi by 2. So we substitute it over here, minus 5 divided by 6 pi into pi by 2, and this again is going to be equal to pi by 2, and this again is going to be equal to 0. So I have this as 8 divided by 3 pi into pi by 2. Now pi can be cancelled off on both sides over here. Remaining this 8 can be cancelled off with 4 times, leaving us with minus 5 divided by 6 2s are 12 plus 4 divided by 3. LCM is going to be equal to 12 minus 5 plus this makes it as 4 times, 4 4s are 16, 16 minus 5. So the answer will be equal to 11 by 12. So the mean square value of the process is going to be equal to 11 by 12. Now this problem, what did we do? We solved it using the integration formula which we have learnt earlier. From this step I can take a type 2 method. So this is going to be my type 1 where I use integration. I can take a type 2 method which involves applying the inverse Fourier formula. We will see that also in the same problem, so that you can choose whichever way you feel comfortable for doing. So I am solving the same problem using type 2 method also. So what I have over here is my expected value of x square of t, which is my rxx of 0, is going to be 1 divided by 2 pi integral from minus infinity to infinity. The partial fraction has now been split as minus 5 by 3 divided by omega square plus 4 plus 1 divided by 2 pi integral from minus infinity to infinity. So now I have this to be equal to 8 by 3 divided by omega square plus 1 into d omega. Now I am going to use my type 2 to solve the problem. What is going to be my type 2? So we will go to see that. My type 2 says that rxx of tau is f inverse of sxx of omega, and my f inverse of 2 alpha by alpha square plus omega square is e power minus alpha into mod tau. So this is going to be my sxx of omega. So I have this to be equal to f inverse of, so let me find my rxx of tau to be equal to f inverse of this quantity. Let me take, this is going to be my sxx of omega, which has been split as partial fraction, minus 5 by 3 divided by omega square plus 4 plus f inverse of the second factor, which is going to be 8 by 3 divided by omega square plus 1. So notice I will not be having this 1 by 2 pi and all, because what we wanted was only sxx of omega. So our sxx of omega is going to be just this partial fraction alone, which was then split as factors of a divided by plus b divided by. So we have it of this format. Now I need to adjust these terms, which means let me pull this 5 by 3 outside. So I will have f inverse of 1 divided by omega square plus 2 square plus 8 by 3, let me pull it outside, f inverse of 1 divided by omega square plus 1 square. Now see our requirement. Our requirement is going to be 2 alpha in the numerator. So 2 into, what is going to be my alpha? Alpha is going to be equal to 2 for this first factor. So I want 2 into 2 in my numerator. So in which case I will be multiplying by 4 and dividing by 4 to balance it. Now when it comes to the second factor, what I want is 2 into alpha. What is alpha in the second factor? Alpha is equal to 1 in the second factor. So I want 2 in the numerator. So I multiply and divide by balancing it with 2. So this balancing step is going to be the important one over here. The remaining things can be solved very easily. So you will have to balance your numerator according to the 2 alpha factor by multiplying and dividing it with the required constant. Okay. So if you are done with this, then the problem will become very easy for us. So we move on with this in the next stage. So I have this to be equal to minus 5 by 3. And I have 1 by 4 with f inverse of 2 into 2 divided by omega square plus 2 square. The second factor, 8 by 3 into 1 by 2, 8 by 3 into 1 by 2, f inverse of the required factor is 2 into 1 divided by omega square plus 1 square. So now I can replace this as minus 5 by 4 3s are 12, and this entire quantity can be replaced with that of e power minus alpha into modulus of tau. So what is going to be alpha for me? In the first factor, alpha is 2 for me. So I have this to be equal to minus 5 by 12 e power minus 2 into modulus of tau. Similarly, for the second factor, what I have over here, I will be having my alpha as 1. So this will give me the quantity as plus 8 by 3 2s are 6 e power minus alpha is going to be equal to 1 times modulus of tau. So this is my rxx of tau. Notice dear, it is Rxx of tau, not Rxx of 0. But what is our requirement? Mean square value, which is my Rxx of 0. So what I'll have to substitute finally? I'll have to substitute tau as 0. So this gives me minus 5 by 12 e to the power of 0 plus 8 by 6 e power 0. So this is minus 5 by 12 plus 8 by 6. So the LCM e power 0 is equal to 1. We need to keep this in mind. So LCM is going to be 12 minus 5. This has to be multiplied by 2. 8 2s are 16. 16 minus 5, 11 by 12. So this is the answer which we get using the inverse Fourier transform method. The answer was 11 by 12. And we can see that what we had as the answer using the integration formula, that is type 1, was also the same 11 by 12. Over here directly you had Rxx of 0 when you used integration, but when you use inverse formula you will be getting only Rxx of tau. So you need to go one more step ahead to substitute tau as 0 to get your final answer. So both the methods have been now taught to you or has been introduced to you. You can choose one method which is going to be more suitable and which you feel comfortable working with. Try exploring more problems. You will feel the problems to be very easy and handy when you work more and more. Thank you.